Hello students, in previous lecture we have learned about the irrational numbers and the concepts which is related with the irrational numbers, that is decimal form of those irrational numbers and the proof of irrational number which is studied in the form of theorems. Then see here, we are going to study about the few new concepts which is related with the irrational numbers as well as real numbers. Then irrational numbers, all of you have studied about that. Those are the numbers which is their decimal forms are non-terminating as well as non-recurring numbers. Then those irrational numbers we can represent on number lines also. The rational numbers which we have already represent on number line as well as we can represent the irrational numbers on number line also. Then one of the example from practice set 2.2 I am going to discuss with you. That is, see here, there are few irrational numbers are given and here question is given that show or represent the following irrational numbers on number line, that is square root of 5, square root of 10, square root of 2 or square root of 3 or square root of 7. Then we have to represent the square root of 2 or square root of 3 on that number line. Then how to represent this irrational number on number line? Then first of all we have to remind the concept that is Pythagoras theorem. According to Pythagoras theorem, see here, suppose it is a triangle, that is OAP, which is right angle triangle, and suppose here OA is 1 unit, AP is also taken 1 unit, then according to Pythagoras, OA square plus AP square is equals to PO square. Therefore, OA square 1 square plus AP square 1 square is equals to PO square. Therefore, 1 square 1 plus 1 square 1, that is 2, is equals to PO square. Therefore, taking square root on both sides, therefore OP or PO, that is PO, that means OP is square root of 2. Here square root of OP square, therefore here square root of 2 is taken here. Therefore value of OP, that is square root of 2. Then OP is a distance, that is equals to the square root of 2. The same concept which is used to represent the irrational numbers on number line. Then see here, first of all draw a number line on the in the textbook using the geometrical instruments, that is ruler or any one of the geometrical instrument. Then see here, first of all we have to label that number line, that is N is a number line on which O is a point which is known as origin, and to which that point 0 coordinate is related to this. Then we have to draw the few more points at equal distance to represent that irrational number on number line. See here, point A is there, B, to which positive numbers, that is 1 and 2, is related with that point A and point B respectively. Similarly, see here, point L and point M, to which -1 and -2 coordinates are related with point L and point M respectively. Then see here OA, this distance is 1 unit. See here, 0 to 1, that is 1 unit. Then we have to draw the perpendicular line at point A using set square. Then see here, using set square, we have to draw the perpendicular line passing through the point A. Then see here, we have to make the mark at 1 unit from point A. That is, see here the distance OA is 1 unit. Therefore, we have to make the mark at 1 unit, that is, which is known as point P. Then see here, distance OA is 1 unit as well as AP is 1 unit. Then we have to draw the segment OP. Then see here, OAP is a right angle triangle. Here OA is 1 unit while AP is 1 unit, and therefore OP is, that is distance OP is square root of 2. Then see here, using that one needle compass, we have to take the distance equals to the OP, then putting the needle on point O and taking the distance equals to the OP, we have to mark on the number line which lies between point A and B, and that point which is labeled as that point C, through which the coordinate is related is point that is root 2. That means we can represent that irrational number on that number line. Then how to represent square root of 3 on that number line? Then see here, according to the same concept, that is Pythagoras theorem, we have to taken here OA is equals to 1 and AP, that we have to taken square root of 2. The distance of AP now, it is square root of 2. Therefore, putting the value of OA and AP in this equation, that is 1 square, root 2 square is equals to OP square, that is OP square. Therefore, see here, 1 square is 1 plus root 2 square, see here, root 2 into root 2, that is root 4, therefore it is 2. That means here root 2 square is 2, that is OP square is equals to OP square. Therefore, see here, 1 plus 2, that is 3, is equals to OP square. Therefore, here OP square is 3. Therefore, OP is equals to, that is taking square root of both sides. Therefore, here root 3. That means OP value, that is root 3. Then, see here, when OP becomes root 3, when OA is distance 1 and AP distance taken as a root 2. Then, see here, we have to taken here OC. See here, OC, we have to put here that OC. OC, that distance is a root 2 distance. Here root 2 distance. And we have to label it here P dash. Then here P dash C is a distance of 1 unit. Then we get OP dash root 3. Then see here the same figure or diagram or concept is used here. That is already here OC is this distance is root 2. See here, that is the distance root 2. See here. Then we have to draw the perpendicular line, that is which is perpendicular to the line N passing through point C. Then we have to take the distance P dash C, that is 1 unit. Therefore, we have to mark here that from point C at 1 unit. Therefore, here point which is obtained is a P dash. Therefore, here P dash C is 1 unit, that is 1 unit, and OC is root 2 unit, that distance is. Then we have to join OP dash here, and therefore that OP dash is a root 3. This distance is root 3. Again using one needle compass, then we have to take the distance in that one needle compass, that is OP dash, and putting the needle on O, we have to draw the line on number line. We have to mark on number line. Then we get one more point on number line between A and point B, that is point D. See here, that point D is nothing but the coordinate which is related with that point D is root 3. That means here point C, of which coordinate is root 2, and here point D, to which the coordinate is related, that is root 3. Like that we can draw or represent root 5, root 10, root 7, any irrational number on that number line. Then one more question we have to discuss here from practice set 2.2, that is question number 4. See here, in question number 4, write any 3 rational numbers between 2 numbers given below. That means here, taking one of the example from it, here one of the example is given 0.3 to 0.4. That means 0.3 is one of the rational number, as well as 0.4 is also another rational number. And between these 2 rational numbers, we have to find the 3 rational numbers which lies between 0.3 and 0.4. See here, between 2 rational numbers there are infinite points are there, as well as infinite coordinate numbers lies between those rational numbers. See here, between 0 to 1 there are infinite rational numbers are there. Similarly, here between 0.3 and 0.4 infinite rational numbers are there, and we have to find it. Then see here 0.3 is given in 1 digit decimal form, that is 0.4 is also 1 digit decimal form. Then we have to convert this 0.3 into digit decimal form, that is 0.30. That means 0.3 means 0.30, as well as 0.4. See here, 0.4, that means 0.40. Then see here, 0.30. After that, the number which is obtained here, 0.31. See here, 0.30, 0.31, 0.32, and those numbers are less than 0.40. Therefore, 0.33, 0.34, 0.35, 0.36, 0.37, 0.38, 0.39, and 0.40. See here, that number is 0.4, and 0.30 is 0.3. Between these 2 numbers, infinite numbers are there. Out of that, we have written few rational numbers. Then similarly, you can find out the rational numbers from the given two rational numbers. As well as there is one more method that we can find out the rational numbers between the given two rational numbers. Then see here, let us consider here 0.3 is x and 0.4 is y. Therefore, to find out the rational number lies between those two numbers, then we have to write x plus y upon 2. That is 0.3 plus 0.4 upon 2. Then we get 0.7 upon 2. That is 0.35. 0.35 which lies between 0.3 and 0.4. Similarly, one more rational number, that is, now we consider 0.3 as a x and 0.35 as a y. Therefore, taking the average of 0.3 and 0.35, that is 0.3 plus 0.35 upon 2. Therefore, we get 0.65 upon 2, and therefore here 0.325. 0.325, that is one of the rational number lies between 0.3 and 0.4. As well as taking 0.325 or 0.35 and 0.4, we can get few more rational numbers which is lies between 0.3 and 0.4. See here, 0.35 plus 0.4 upon 2, that is 0.75 upon 2. Therefore, here 0.375. That means here 0.35, 0.325, 0.375. These are the three rational numbers which lies between 0.3 and 0.4. By getting the rational numbers which is lies between the given numbers, that is the one more method we can use for it. Then see here, one more example is given here, that is minus 2.3 and minus 2.33. Then see here, focus on the digit numbers after decimal points. Here 2 digits are there, therefore we have to convert this into 2 digits. Therefore see here, minus 2.30 and minus 2.33. Therefore we can get minus 2.31 minus 2.32. Like that we can get only two rational numbers. But if we convert this number into 3 digit in its decimal form, that is minus 2 point, that is after decimal point 300. See here, minus 2.300 means minus 2.3, as well as here minus 2.33 means minus 2.330. Then we can write the numbers between those, that is minus 2.301 minus 2.302. Like that we can write the numbers between minus 2.330 and minus 2.300, that is minus 2.302. Like that we can write minus 2.310 as well as minus 2.311 dot dot, that is minus 2.320 as well as minus 2.321 to minus 2.30, that is 330, and that is nothing but that number. That means we can write many rational numbers. Dot dots are there, means there are few more rational numbers which lies between those two numbers. Then you may do the practice of solving those type of examples from practice set 2.2. Then see here, one more concept that is here the set of rational number and irrational number together are called as real numbers. Then we have to remind few properties of real numbers. Then see here one of the property, that is, let us consider A, B and C are any real number. That means it may be rational or irrational. Then there are three possibilities. That is, first, A is equals to B, that means those two numbers are same. Or second, that is A is less than B, second one possibility. And third one possibility, that A is greater than B. There are three possibilities lies between any real numbers. One more property, then see here, that is, if A, B, C are any real number, then if A is less than B, and B is less than C, then A is less than C. That is the one of the property. We can prove that by taking example of it. If 3 is less than 5, 5 is less than 7, then here 3 is less than 7. Then few more properties which is related with the real numbers. That is, third one, see here, if here A is less than B and here C is greater than 0, that means C is positive real number. Then here A into C is less than B into C. That is the one of the property related with this. See here, A into C is less than B into C. Here A, when A is less than B. See here, if 3 is less than 5, then here C is positive number, that is plus 7. Therefore here 3 into 7 and 5 into 7. Therefore here 21 and 35. Between this 21 is less than 35. Therefore this property get proved here. Similarly, we can write here, if A is less than B and C is positive number, then see here A plus C is less than B plus C. The same property, see here, if 3 is less than 5, then if we add 3 plus same number into it, that is 3 plus 7 and 5 plus 7, here 3 plus 7, 10 is less than, that is 12. That means that one of the property that we have to prove here. Then see here, the same property I am taking here to prove one of the another property. See here, if A is less than B, and here if C is less than 0, that means C is negative real number. Then A into C is greater than B into C. See here, if 3 is less than 5 and here C is negative number, that is minus 7, or taking minus 2 here, any negative number you have to take here. Then here 3 into minus 2 and 5 into minus 2. Then 3 into minus 2, minus 6, 5 into minus 2, minus 10. Therefore here minus 6 is greater than minus 10. Then all of you have studied about the orderness on the number line. That is about the properties, few properties related with the real numbers, which is applicable to irrational number as well as rational numbers both. One more concept I am going to discuss with you, that see here, if here square root of a is equals to b, that means here we can convert it into b square, taking squares on both sides. B square is equals to a, that means square of root a is a and square of b is b square. That means here taking one of the example of it, that is here square root of 5 is equals to x, and taking squares on both sides, therefore x square is equals to root 5 square means 5. That means see here square of any real number is always positive. See here square of any real number is always positive, it never be negative. But see here one of the example I am taking here, instead of 5, square root of root 5, let it consider x. Therefore taking square on both sides, then we have to square on both sides. Root 5 square, that is root 5 square is equals to x square. Therefore root 5 square is that is minus 5 is equals to here x square. That means here x is a real number. X is a real number and square of that real number, here we get minus 5. That means x is a real number and here real number, that is root minus 5. Root minus 5, if it is considered as a real number, then when we taking square of that real number, then that square becomes square of root 5. Here square of root minus 5 is minus 5. That means here square is negative number. Here square is negative number, and I have already told you that square of real number is never be negative. But here minus 5 is square of root minus 5 and minus 5, that square is negative. Therefore root minus 5 is not the real number. It is not the real number because square of real number never be negative, and here square of root minus 5 is minus 5 and here square is negative. Therefore as square of this number is negative, therefore this number is never be real number. That means I am focusing here that property again, square of any real number is always positive, it never be negative. If it is negative, then that number is not the real number. That is about the irrational number as well as real numbers. Then in next lecture we will study about the few new concepts like surds. Then till you may solve the examples from practice set 2.2. Thank you.